Here we'll be making our first foray into synthesis of mechanisms with a simple problem of designing a variable stroke windshield wiper. We would like to control the start and end positions of this wiper stroke with a few changes to its link lengths. The goal or output motion for a wiper is of course angular oscillation, while the input will be coming from a uniform rotation of an electric motor. Now completely rotating links are called cranks, while links in angular oscillation are called rockers. So let us start with a simple crank rocker 4-bar. To possess a crank, our 4-bar must satisfy Grashoff's criteria, which says that the shortest and the longest link should add up to something less than the sum of lengths of the other two links. Once we have satisfied that, we can get a crank. So here we have a crank. Now let us think about the rocker. So this is the schematic configuration we have. At the fixed link, on one side we have a fully rotating pin indicated by a full circle here, and on the other side it will have a partially rotating pin indicated by this partial arc. So that is going to give us a crank rocker. So let us consider the extreme positions of this mechanism because they are going to give us the start and end angles. So I'm going to drag on this crank AB and watch the rocker DC over here. So as we drag, one extreme, the leftmost extreme, is reached when our crank AB is overlapping on the coupler BC. The other extreme is reached when again they become collinear, but this time instead of overlapping they are one next to the other. So their lengths are kind of getting added. So we have chosen a basic crank rocker mechanism. So it will have a support, then a crank, a coupler and a rocker, and the lengths we'll call as L1, L2, L3 and L4. The extreme positions are given by these two triangles. The start angle here is defined by this configuration where the coupler overlaps the crank. So this side of the triangle is L3 minus L2, while the end angle is defined by this configuration where the coupler and crank align themselves one next to the other. So this side of the triangle becomes L2 plus L3. Then to these two triangles we can apply simple cosine rule so that the relation between these angles, start and end angles, and the link lengths can be established. So these are some of the equations and variables involved here. These are just simple expressions coming from the cosine rule. And finally here we have our design, the windshield wiper whose stroke can be varied. Let us verify the design. So we are going to change the start and end angle values. We start with a configuration where the start angle is 55, end angle is 115. Let's verify that first. So on this side we have come up to 55. Starting there we will go right up to 115 as specified here. Now let us try changing it. It's just a matter of simple editing of the text. So I'll change this to 45 and then I'm going to resolve my mechanism. Basically I'm solving those equations again. You might have noticed that the link lengths changed momentarily, and now we are starting from 45 degrees here. So starting with 45 degrees, it is going up to 115 as before. We can of course change the end angle as well. So instead of 115, let's make it 125. Resolve as before. On the right extreme, it is going up to 125 degrees. And here it is coming back to 45 degrees as before. So with a simple application of cosine rule to two simple triangles, we are able to design this variable stroke windshield wiper.